conservative force and non-conservative force. Okay. So what is conservative force? So first is that work done is path dependent. Work done is path dependent. Okay. Oh, sorry. Path independent. This one is path independent. Okay. Here the work done is path dependent. Okay. Second is work done is in a closed path. If you consider work done in a closed path will be 0. Work done in a closed path is 0. Work done in closed path is 0. Okay. And second, work done in closed path. Why it is 0? Because initial and final point is same. Because initial and final point are same. Because it depends on the initial and final points, and here initial and final points are same, so work done will be 0. So initial and final points are same. Okay. And here initial and here the work done will be non-zero in a closed path. It can be non-zero. It can be non-zero for closed path. Okay. Then we can define here potential energy. For conservative forces, we can define potential energy. Potential energy is defined for these forces. Okay. And how potential energy is given? The change of potential energy is given by negative of work done by conservative forces. Okay. And here potential energy is not defined. Potential energy is not defined. Okay. Next is we can write example. So example are gravitational force, spring force, electrostatic force, and here we can write example as friction force, resistive force, any resistive forces, any kind of resistive forces. Okay, so it can have various kind of friction forces. Viscous force is also in this category. So resistance, the wire resistance is also in that category. Okay, so resistive force, air resistance, liquid resistance, and induced electric field force. Induced electric field force. Okay, so these are the basic differences between conservative and non-conservative forces.